Okay, on to trig functions. The theorem we're going to prove is the following. If f of x is equal to the sine of x, then f prime of x is the cosine of x. Proof. F prime of x is equal to the limit as h goes to 0 of f of x plus h minus f of x over h. And what does f do? It takes the sign of whatever is in the brackets. So this is the limit as h goes to 0 of f of that. Oh, you mean the sign of that? Minus f of that. Oh, the sign of x. All over h. And this is equal to the limit as h goes to 0 of the sine of x plus h. And we're going to use the sum rule for sine. So it is the sine of x times the cosine of h plus the cosine, plus the cosine of x times the cosine of h. Now, that's not right. Excuse me. I apologize. This is plus the sine of h times the cosine of x. Minus the sine of x. And this is all over h. And this is equal to the limit as h goes to 0 of, well, I notice that these two, they have a sine x in common. So let's factor it out. The sine of x times the cosine of h times the sine of x over h plus the sine of h times the cosine of x over h. And of course I have just a little typo here. This should be the sine, the cosine of h minus the sine, minus 1, minus 1, minus 1. Okay, so we have the limit of that. And what happens is that since we have the sum, I can take the limit of this plus the limit of that. So the limit of sine of x times cosine of h minus 1 over h plus the limit of h goes to 0 of sine h times cosine x over h. Now, for each limit, we have a product. For each limit, we have a product. So, I can take the limit of the first, which has nothing to do with h is, and take the limit of the first times the limit of the second, cosine of h minus 1 over h, plus the limit of the first, I'm going to call that the first, the limit of sine of h over h times the limit as h goes to 0 of cosine x. Now, we're going to have to work on this limit separately. But the first limit, sine x has nothing to do with h. So it's just the sine of x times whatever this limit is. Plus, this limit, you should know, is 1. Times, well, with respect to h, this is a constant. So it just stays cosine of x. So we need to get a formula or we need to evaluate that limit. Let's do that down here. The limit as h goes to 0 of cosine h minus 1 over h. Well, first of all, if you plug in 0, you get 1 minus 1 or 0 divided by 0. So what I'm going to do is I'm going to multiply top and bottom by the conjugate, which is 1. I have the limit as h goes to 0. In the bottom, I'm going to have h times the cosine of h plus 1. And in the top, I'm going to have cosine squared h minus 1 squared. But that's sine squared. Remember, sine squared plus cosine squared is 1. If I switch these two, I get that cosine squared minus 1 is negative sine squared. So this is the limit as h goes to 0 of negative sine squared h over h times cosine of h plus 1. This is equal to, excuse me, rid of this. This is, so above this h, I like to have a sine h. So it's the limit as h goes to 0 of, say, negative 1. That took care of that negative sign. Sine h, well, okay, times sine h over h. So I took care of the h in the bottom, and one of the sine h's in top, times another sine h over this, cosine h plus 1. So the limit as h goes to 0 of negative 1 is negative 1, times the limit as h goes to 0 of sine h over h is also 1, times this one. Well, the sine of 0 is 0, and the cosine of 0 is 1 over 1 plus 1. This is a well-defined number. It's 0. So we have negative 1 times 0, which is 0. Okay, so this limit right here is 0. Okay, times 0. And then we get this is 0 plus this is cosine of x, and 0 plus cosine x is cosine x. And there's the derivation for the derivative of sine x.